So this is our chapter 3 test review. All right off the bat, there are 10 multiple choice. And okay. 2 free response. So that will make this test worth a total of 18 points. Okay? Because I will always grade every single multiple choice out of 4 points. Because that is the AP standard. So what did I say? Multiple choice? Sorry. Yes. The free response will always be out of 4 points because that is the AP grading standard. So, and I'll try to be forgiving on those because the first free response has parts A, B, C, D, and E. And the second one has A, B, and C. So the first one is quite large. Alright? Number 11 has many parts. Number 12 is not too many. Okay, let's look at this. So, no problem. Identify in context. The explanatory and response variables. And response variables. Everybody did that awesome on the quiz. So, I think there was only one person that got a little tripped up, and I think that you know what you're talking about. But, all right. All right. Given a least squares regression, equation, make a prediction. No problem, right? They give you an x value, you plug it in, it spits out a y hat value. That's it. That's what you're being asked to do, right? That would be pretty much exactly like 3.2 letter B. Okay? Exact thing. But it's a multiple choice question. Be able to calculate a residual. What's our formula? Y minus y hat is our residual. It's also time, so I'm going to give you guys some formula sheets tomorrow. I'll tell you which formulas you need on these sheets. They'll be your sheets that you keep for the year. They're not super helpful. They're really not. You should know these formulas. I don't believe this one's on there. So I'll show you what the AP formula sheets look like. We're getting there now. So look at that. I don't give them to you at first because it looks really confusing. They're nasty looking. I don't want you to get confused and try to figure out what's what yet. Because the only formula you've used so far up to this point was z equals x minus mu over c, right? Pretty much. All right. Interpret correlation. Or rather, let's understand how transforming data affects correlation. So I mean, and what's going to happen? Like we know, if we're going to transform data, we have this on the take-home quiz, right? If you're going to subtract 50 from every unit, it's not going to change your correlation at all, right? So keep that in mind. What happens if you multiply every single observed value by 20? Is it going to change your correlation? Would it change the distance from the mean? On average? Not really. Everything's going to, right? It's just going to expand it. But those distances, since we're subtracting them, they'll be, yeah, cool. No. All right. Interesting. Let me make sure. Trying to understand this question.
Whoa, it's the sound of thunder.
Is it? Oh, thank you. Oh my gosh. Wow, that's a tricky question.
Oh, nice.
Hey guys. Remember, correlation is always between -1 and 1. Alright? That took me a minute. I had to stare at that for a second. I was like, forever. Yeah. That's the pirate's favorite variable. They like correlation. I just recorded that. For every Halloween, I come as a pirate, but I'm a.
Have you seen those t-shirts where it's like I ate some pie and it's delicious, but it's like I and then like 2 to the 3rd power, the sun into the pie.
I actually have a shirt with the pirate skull and crossbones on it, and in the skull and crossbones, the eye patch, there's a pie, and it says pirate. That's why I always come as a pirate. I wear that nerdy shirt for Halloween. Nerdiest story ever. I bought it at an international calculator convention. Yeah, I said that I went to worship, to rehearsal for worship at church, and I told that to one of the worship pastors, and he was like, just for the future, don't ever tell anyone that. Just keep that one in the locket. Okay, so you're going to need to interpret slope. And y-intercept of the, I'm going to least squares regression equation. Remember, always, 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 always in context. Please. Please don't say it goes down by 0.52 or whatever, right? You wouldn't be wrong, but it's not in context, right? Don't interpret it using x and y, right? Make sure that you do it in context. All right. So also, interpret the appropriateness of least squares regression using a residual plot. Right? Remember, if you're residual, and I am not putting labels because this is not real. If it looks like this, it's bad, right? If it looks like this, the data is probably nonlinear, right? And therefore is not appropriate for least squares regression, right? It's not appropriate to model it using a linear equation because it ain't linear.
Change it up.
All right. Hey. Study this. Okay. Remember, you have a predictor, your Minitab output. It'll say predictor constant, and then it'll have it'll say it varies, right? Just remember, this is going to be your slope. And that's all you need from that, right? And then you might have an R squared value, and then you'll also have a standard deviation. Just remember where those go. Remember, constant means y-intercept, okay? From there you can deduce what your slope is, right? It'll always have standard error, T and P. We're not using that yet, right? Remembers? That's the only thing that was missing from your take-home. There wasn't a Minitab output. I didn't like that. All right. And then there's a cool roundabout question. All right. So on our free responses, 9 and 10 are kind of going over the same skills, just in different contexts. So hey, free response. You just have to interpret I think the first one's fine. Okay, a big one we haven't talked about too much is know how outliers affect the least squares regression. So an outlier will change the slope. It'll also change your y-intercept, but so it changes slope. But more importantly, it has the largest effect on your correlation. On R. And be careful, okay? R is correlation, R squared is your correlation coefficient. You cannot use them interchangeably. One says something totally different than the other. Yay, another Minitab output. So do make sure you understand how to read the Minitab output. Study, study, study. Minitab outputs. Make sure you know which is the slope and which is the y-intercept. Okay. Do you want me to go over that again a little bit, or is that yes? Okay. Oh, there it is, right? Your slope's always going to be this one on the bottom. Yeah, and this is just your title row, right? You're going to actually have your numeric data here. So y-intercept on top, slope on the bottom. Yes. Make a Minitab output? It doesn't do that. Neither does the Inspire. Minitab is a computer program. It's a statistical analysis program that we don't have. So, all right. I gotta keep track of the two bells. Okay, sweet. Again, you're gonna have to interpret the standard deviation of your least squares regression line. Some contextual stuff. All right. All right, so you're going to have to actually use some formulas for number 12. And those are the formulas that I'm going to give you. And I'll actually highlight which are which for you. So I'm going to give you a big formula sheet. And I'll actually tell you which formulas you're going to need to use. But have a look. Have a look over the formulas used to create the least squares regression line. The least squares regression equation. Yeah? Have a look at them. I'm going to tell you which are which. I'll go ahead and give you a formula sheet, tell you which formulas to look at, which formulas are which, just to give you a jump on this problem, because it's going to be It's very mathematical. And I'll if you have questions about it, I can help you out. Also, remember that if you're given you can get r squared. How? Just square it, right? If you're given r squared, you can get r by taking the square root of your correlation, okay? You're going to have to do that. And that's it, and then you're going to have to interpret it. 12a is rough. 12a is hard.
Scale 1. Set.
Honestly. It's the only one. It's the one. 12a is the only one on the test that is gnarly. Super gnarly.
Is that like what Mission Impossible hard?
No, it's not Mission Impossible hard. It's you're gonna think about it for a little bit. And if you're stuck on it, I'll refer you to the equations that you need to use, to the formulas that you need to use. It really has to do with the way that you actually calculate a least squares regression line by hand, if you were to do it by hand. Which I think you had to do in the homework. So you should have a jump on it. Yes. Seven was knowing when it's appropriate to use a residual plot. And 11. Oops. There's no 11. I decided to go straight to 12. So there's the last of it here. All right.